Welcome to our next video in section 2. We're going to talk about a little bit more complicated topic in this video. We're going to talk about projecting a vector, which we often call u, onto another vector, which often is called v. And so the technical description or notation for that is right here. The projection of u, and then there's a little v right there, so onto v. And they give you a very complicated formula. I'm not going to get into why this formula works so much in this video, but I might make another one that kind of runs through that for you. This is not by magic, but let's just go ahead and try to use this. So let's just look at the formula first. It's the dot product of the two vectors. That's just going to get us a number. And then you're dividing that by the magnitude of vector v being squared. So that's another number. So a number divided by a number gets us a number. All this stuff in the parentheses here is just a number, and then we multiply that by a vector. So when we take a number by a vector, we just scale the vector here that's at the end. So you'll see that visually in just a second. And then my other little hint here that I put in the notes is just to remember that you want to drop a line from u that's perpendicular to v. All of that will make much more sense as we look at a picture of this on Sketchpad. So this is our vector u. We're going to project this onto vector v. So we need to have vector v. There's vector v right here. So too much there, but I can move both of these things around pretty much. But just to start off, let's just make vector v be on the x-axis going to the right. Okay, there might be times where you need to extend vector v a little bit, or put kind of a dashed line there. So, oops, sorry about that. There's a dashed line that's now running through there. There might be times where that's helpful. But this is kind of my big hint here, is when we've come up with this projection, you want to make lines that are perpendicular to vector v that connect with the arrow of u, and then with the kind of a point at the end of u, which also happens to be the point at the end of v. And this distance right here is what we call the projection of u onto v. So there's another black arrow right here, and that is the projection of u onto v. So it's almost like the shadow that is created when the sun is way, way, way up here. The shadow that's created from vector u onto the ground here, which is vector v. And as I move where u is, you can see that shadow can extend and go way beyond where vector v actually ends right here. So that's why that dotted line can be kind of helpful. Okay, but also, if I choose to move vector v, now that projection of u onto vector v, it's also angled. It's always going to go along whatever angle v or vector v is. It's just it could be short. I could extend this. Now it's going to be longer than vector v. That's always kind of the goal here, is to figure out what's that shadow that the sun way directly above vector u, perpendicular to v. It's got to be somewhere up here now. What's that shadow? And that's what we're trying to find in this picture. So I'm going to just kind of get rid of a few things here just to kind of clean it up. Maybe one thing I should mention, I've put the names of the vectors at the very tip of the arrow. And then what you see here in the kind of absolute value symbols, that means magnitudes. We're talking about the magnitude of vector u, the magnitude of vector v, the magnitude of the projection of u onto v, which is often symbolized with u sub 1. I just can't do subscripts in here. So, okay, so in our question, try to set this up here. I'm going to hide the projection there. We want to find the projection of 6, 2. So that's what u is. So go to 6. Let's see, 1, 2, 3, 4, 5, 6. Go up 2. So there is the vector 6, 2. We're going to project that onto the vector 5, negative 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So as we set this up, if it's helpful, there's our perpendicular lines right there. So the sun is somewhere up here shining perpendicular to vector v, and it is going to create that vector right there. So we're trying to figure out what that black vector is. You can kind of see it's 2, negative 2, but I want to show you mathematically that our formula kind of works. Okay, so I would suggest you kind of draw this picture in your notes in that little space there, way on the left side, and then I'll just kind of walk you through some of the other things that you would want to think about here. So in our formula, maybe if I write down our formula, just so we can reference that, the projection of u onto v, so that's what we mean with u sub 1. Our formula says take the dot product of u and v. Okay, you're going to divide that by the magnitude of v squared, and then to all that, you're just going to multiply that by vector v. So I need to figure out a few of these missing items here. So the dot product of u and v, okay, if I went through that, I would have 6 times a 5 plus a 2 times negative 5. So that's 30 minus 10. Okay, so that dot product was 20. Okay, let me switch colors a second. And if I found the magnitude of v and I square that, algebraically that just means big square root here. I would take the x value and square it, take the y value of vector b and square that, and then I would be squaring that entire thing because the stuff that's in the square root is just magnitude. I want magnitude squared. So obviously the outside square root the outside squared symbol is gonna cancel off with the square root symbol there. So really I just have a 5 squared plus a negative 5 being squared. Both of those are 25. In the end, this will get me 50. So I just go right back up to my formula, switch colors here again, plug in the numbers. The dot product was 20. The magnitude squared was 50. And then to that, I'm going to multiply, that is a vector symbol, believe it or not, by the original vector v, which was 5, negative 5. So all of this work would just get a scalar out here. So we're going to take 2/5 basically of whatever we would get right there. So you can kind of ponder that for a little bit, think about what you're going to end up with. But if you were to distribute, color again, if you were to distribute this whole fraction to there and to there, you would end up with another vector of 2, negative 2. So in the end, it does match up with what we see here. This black vector goes to the right and 2 down. That's what this is telling us right here. Okay, so the other thing that we might want to do, I think the instructions even say this, then write, the tail end of that question says, then write u, so the original vector u, as a sum of 2 orthogonal vectors, that means perpendicular vectors, one of which is the projection of u onto v, so one of which is this. Well, right here, this is perpendicular, this is a right angle. So if I were to add in one more vector right here, these are orthogonal. If I add this and this in vector language, it means the same thing as just single vector u. So this, I often write it as u sub 2. It's just the one that's going at a 90-degree angle there, and that's something that we could figure out right now as well. So we just want to have another way of kind of writing out, I guess, what u is, and certain applications it's helpful to know that. So say that u, the original vector, should equal u sub 1 plus u sub 2. So the original vector u was 6, 2. We know the projection of u onto v, or u sub 1, was 2, negative 2. And so the question is, what do I need to add to 2, negative 2 to get me 6, 2? So what do I have to add to a 2 to get 6? That's 4. And what do I have to add to a negative 2 to get positive 2? And that would also be 4. If you put that all together, it does look like starting at where this red arrow begins, I have to go 1, 2, 3, 4 over, and 1, 2, 3, 4 up to get me where the original vector u ends. Okay, I think that's a good place to stop. I know there's a lot going on there. couple hints. Make sure that you are thinking of always placing this black vector on top of vector v. Always go in a perpendicular direction. I really find that analogy of the sun has to be directly above vector u and going perpendicular to vector v, so it's figuring out the shadow. I think that's incredibly important. And then a lot of it is just plug and chug. Just put it into the formula, see what you get. And then as far as overall answers here, this obviously was one that we used, probably the main answer, but then also figuring out this piece right here and putting all that together is kind of important. But that's enough for me. Let's stop this video.